All right, so the last one we're going to do is we're going to do the graph of the cosine, and then we're going to evaluate some expressions. So the graph of the cosine, very similar to the graph of the sine. It's called the cosine curve. The domain is still all reals. Okay, so your x's range the whole way to infinity and the whole way to negative infinity. The range, so the y values, are still in the interval of -1 to 1. Okay, so it includes those two values but doesn't go above it or below it. So one cycle of the cosine function, which is going to be 2 pi, just like the sine. So one period is 2 pi. The cosine curve repeats indefinitely, just like sine does, the left and the right of the origin. It's symmetric, so this is a change. It's symmetric with respect to the y-axis, and this property tells me that the cosine is an even function. So sine is odd function, and cosine is even. Sine is symmetric to the origin, and cosine is symmetric to the y-axis. Okay, so there's the difference there. So we're going to do the same thing that we did. We're going to connect these so that we get our y-axis and then our x-axis. Okay, we're going to label them the same way as well. So we have pi over 2 here. If you want to cut this in half, it'd be pi over 4. We're only going to do this on one side, but so then we have 3 pi over 4 and pi. Then we have 5 pi over 4 and 3 pi over 2. And then lastly, we would have 7 pi over 4 and 2 pi. I know those are a little crowded, but still understand. The y-axis will still be the same, so we're at 0.5 and at 1, and -0.5 and -1. Okay, so we're still going to use our bell ringer to do this, very similar to the sine function. So if I start at pi over 4, again, remember cosine is actually your x value on the unit circle. Okay, and similarly, we have y equals the cosine of x. That's what we're graphing. So our x is what we put into the cosine, and the y is what spits out, basically. So if we go look at our list here, the first one we're going to do is pi over 4. So if you look, we have pi over 4, which is square root of 2 over 2. If you remember from that last section, we estimated that to be 0.7. So we go back to our graph. So pi over 4 is about 0.7, so we just blue, so we're right about here. Okay. Oh, we didn't actually do 0. So if I do 0, so my x is 0, and I go back to here, I skip that one. If x is 0, my cosine is actually 1, so this is a change. So 0, 1. I have this point up here. It does not go through the origin. Remember, it's not symmetric about the origin, so it doesn't go through it. So we start with these 2 points, then pi over 2, if we check back on our bell ringer, pi over 2 is right here. So pi over 2 is 0 now. So now I'm down here. All right, so remember there are other values in between here. The 30 degrees and the 60 degrees are the pi over 6 and the pi over 3. We have enough points, so we're only going to use these 3 main points to continue on. So 3 pi over 4, if we go back, and we look at our bell ringer, 3 pi over 4 is right here. So this is now about -0.7. So it's square root of 2 over 2. Again, we go forward. I know maybe you're getting dizzy, we'll be changing. So 3 over pi, we come down here, right about there. Okay. If I split back to my bell ringer and I look up the pi, so cosine of pi is actually -1. Okay. So you can kind of start to see this forming. So now 5 pi over 4, you will find out that it is negative square root of 2 over 2, which is about -0.7. And then 3 pi over 2 just sure I'm doing this right, I'm going to go back. 3 pi over 2 is right here. So it's at 0. So that looks like where my graph was headed anyway. So 3 pi over 2. So it's essentially the same type of graph. It looks very similar, except it ends up being shifted, like off kilter. So sine is at 0, 0. Cosine is 0, 1. And then it kind of starts the same type of curve that looks the same. So if I would go to the left, I know I'm going to finish that out in a second, but if I go negative pi over 4 here, I actually end up at the 0.7. So we end up there, and then negative pi over 2 actually puts me at 0. Okay, so you can kind of see that it's going to look like this. Not a very pretty drawing, but so it's going to continue on. That would be one period of it. I should have made this curve. Okay, so that's 2 pi right there. Okay, so that's one period. It's going to continue to kind of repeat. So if I go over here, 7 pi over 4 would put me at the 0.7. And 2 pi puts me at positive 1. So, and it's going to end up curving back down around. Okay, so we're just going to draw an arrow because we're not going to continue our graph, but it would end up coming back down and continuing. If we go farther to the left, so this was negative pi, negative 3 pi over 2, and negative 2 pi. So between here, I end up giving myself a negative square root of 2 over 2, if you look it up. If you were to look that up, it'd be negative 3 pi over 4. So that puts me at about negative 0.7. And then negative pi puts me at negative 1. And then in between here puts me back at the 0.7, negative 0.7. And then negative 3 pi over 2, it puts me at 0. So you kind of see how this forms. I'm in here, or in between these two, which is negative 7 pi over 4. I guess I didn't label this one. Negative 5 pi over 4. So this would bump me back up to the 0.7, and then negative 2 pi would put me at positive 1. So if I continue my graph, it'll look like this. And again, it continues on either end. It's just, I don't want to keep going. For the most part, this is the graph you will see. And if you look, if you would draw this line down the middle, so straight down the middle, that's the y-axis, you can see that it's symmetric. If I stand back, it looks like a W to me. So I could fold my right side onto my left side, but folded it on that y-axis. So that's why it's an even function, because it is symmetric about the y-axis. Okay, it also has these values down here. So this is what maybe it looked like if you build a table. We put those values on there. We just estimated in decimal form so that we could put them in the appropriate place. All right. So I hope that helps you. We're going to go on to evaluating. So sine and cosine expressions can be evaluated by using curves. Okay. It helps you determine the height of each curve at specified x value. Okay, so the height is really ends up being your answer. So follow the x-axis out. Okay, so to the right or to the left. Extend it as needed, or if you can think about it in your head. Since the curves are periodic, their y values end up being repeated, so you don't actually have to keep repeating. You just have to figure out how many cycles it's been. So it can be easily calculated even for x values as a long distance from the origin, both positive and negative directions. Okay, so if I go ahead and look at these examples, I'm going to refer to this sine curve down here. I wrote it down here. It should look very similar to the one we drew. I know that it's not the exact same thing, but So the sine of 9 pi over 2. So if we think about 9 pi over 2, I want to think how many 2 pi's fit into that. So 2 pi fits what number of times? So if I think about this as 8 pi over 2, and then a pi over 2 added, okay? 8 pi over 2 ends up giving me 4 pi, which is how many 2 pi's? Well, it's 2. So that means there are 2 cycles, and then I add pi over 2. So really all I have to do is look up that pi over 2. So I'm looking for the sine of pi over 2, which if I come down to my graph, pi over 2 is right here. Okay, so if I follow along my graph, maybe yours is even more precise than this. So I go over to my x-axis, and then I say, okay, well, what's the height up to here? Well, this point ends up being pi over 2, 1. So that means that the first example, the sine of 9 pi over 2 gives me 1. Okay? So again, I figure out how many cycles there are, and then what's left over is really what I look up. So find the sine of 3 pi. Well, to me, that's like 2 pi plus 1 pi. Okay, 2 plus 1 is 3. So I'm actually looking up the sine of pi. So if I follow my graph, and get rid of this now, and I go to the right, or on my x-axis, I go to the right and I go to pi, okay, well, right there's pi. So the sine of pi is just, oh, sorry, not 1, 0. Okay, and the same thing for the sine of negative 5 pi over 2. If I think about this, yes, it's negative, but the way I kind of think about this is negative 4 pi over 2 minus a pi over 2. If I subtracted those, I would end up with negative 5 pi over 2. So this ends up being, so 2 pi, so it's only 1 cycle. So 1 cycle. And so I'd be taking the sine of negative pi over 2. So because it repeats this way, I don't have to do all of them. So negative pi over 2 would be going left, and then my height would be a negative value, and for me it would be negative 1. So my answer here is negative 1. All right, so that's how you evaluate. You just look at the graph, you figure out how many cycles it is, and then you end up producing it. So, or find the values of theta, where the sine of theta equals 0. So I'm trying to find all the spots on the graph where I get 0. Okay, so if I look, let me erase this. I hit 0 here, which is negative 2 pi. Negative 2 pi. I hit 0 here, which is negative pi. I hit 0 here, which is 0. I hit 0 at positive pi. And I hit 0 at positive 2 pi. So it would keep going on either side. I just don't want to keep writing it, so we're going to write it in a generic way. So if you look, I would really be taking pi and multiplying it, so it'd be plus or minus pi times k, where k is an integer. And I actually wrote too far over, so I'm going to slide this. Sorry if I messed up. And the last one, so we need to figure out where sine is 1. So sine is 1 here and here. So only at pi over 2. And, what's that one? Negative 3 pi over 2. Okay, so the generic form of this would be pi over 2 plus or minus 2 pi times k. So the gap between these is 2 pi, so that's why I'm adding or subtracting 2 pi. All right, that's the end for this video.